Hey guys, welcome back to Genius Learning. All right, so to continue this series for the Physics 1 exams, all right, we got this scenario here. Okay, at 23 degrees above the horizon, we have a plane traveling at 90 meters per second, initial velocity, the magnitude. All right, and when it gets up to a height of 114 meters, which is right above a little dog or a pig or coyote, whatever this thing is, then it drops a package or suitcase or whatever, and the package goes in this direction, right? How far away from the dog will the package fall? All right. Keep in mind that they don't give you this type of picture when you're doing the problem. It's all words. And so it's good to have like rough sketches and some form of idea of what's happening. So for example, this suitcase thing, right? If the plane is all the way above the dog, that's what they say, 114 meters above it to be exact, they drop a suitcase, right? It's probably easy to think maybe it'll just fall straight down. But you have to think that the plane is actually moving in a diagonal way. And so we know that when something is moving in the diagonal, like that, for example, we can express that in velocity x direction and velocity in the y direction. So this thing, this suitcase or whatever, is not just falling straight down, because since it was released at a diagonal velocity, now it's going to come down at a diagonal velocity, right? It's going to come down and still continue to have v in the x, v in the y, at the same time. If the plane, or it was like an air balloon or something, it was just like hovering and it dropped the suitcase, then it would just go straight down because it doesn't have any velocity in that diagonal. So little things to look out for. And it says with distance after the dog, so not from the initial position. Okay, so let's do that. First, let's see, what can we do? What can we use? All right, so this is what I do when I don't know what to do for the problem. Start looking at your formulas. Usually once you start looking at them and thinking stuff, something might click. If we're all the way up here, keep in mind that when you get to the highest velocity, when you hit velocity max on your y, then it's equal to 0. So I'm just gonna put that over here. It's something I would have thought about trying to solve the problem, but so velocity in the y is equal to 0 at the highest point. So this is at the highest point. So probably don't need that now for this video, but I would have probably just thought about it because of the scenario. So now let's do stuff that actually we need. So let's use this formula. I'm gonna look at, I have y, right? I have a change in y, so why not look at displacement formula in the y direction? All right, so I'm gonna write it all out. Sine of theta t minus 1/2 gt squared. All right, so I'm gonna use this. Oh, I think I'm gonna use that. Let's see what happens. All right, and do we have everything? I have velocity initial, right? Because this here that was given to us is velocity initial. Okay, do I have the angle? I have the angle. Do I have the time? No, I don't. And gravity, yes. The change in y, well, it's expanded. Let's open this up. So we got y2 minus y1, right? And then equals everything. Okay, so this is also tricky, but let's see if we can deduce which one is 114. So the package starts up here. So this is my y1 up here. Okay, so since the package started up here, we're gonna say this is y1 all the way up here, and that distance is 114. And then once it hits the ground, that's y2. That's my second displacement in the y, right? Because it came second. So first was I let it go all the way up here. Second is it hit the ground. So the first one is 114, and that's minus here. And then once it hits the ground, it's 0. Don't get this confused. This is critical right here. So I do it like that, just like follow the logic, where it started, where it ended, and just write it right underneath. And you'll see that you're gonna stay with a negative, which is very important for the next part. All right, I'm just gonna rewrite everything. Okay, should have plugged in the numbers, but I'm an idiot. Let's go step by step. So we got a bunch of values, right? Let's plug in the numbers for all this so we can see what's going on. So 114 is equal to 90 for velocity initial, sine of 23, right? We have time, minus 1/2, 9.8. I'm sorry, we don't have time. And then time squared, okay? So we don't have this value and this value. That's an ugly T. Salvage. All right, so we have this equation. Another thing that needs to click when you look at something like this is you have two T's, you have one, and you have nothing. Let's make everything equal to 0. So what I'm gonna do is the T squared value, the number in the front, I wanna make it positive. So I'm gonna move all this to the other side. Okay, and then I'm gonna move this to the other side of the equal sign also. This thing is gonna stay on this side. So I'm gonna move this to the other side. I'm gonna get 1/2 9.8 T squared. So this crosses the equal sign. Now this crosses the equal sign is gonna be negative. So negative 90 sine of 23T, right? And then we're left with this on the same side, which is minus 114. Now everything is equal to 0. This step is critical, crucial, important, okay? Because now when you look at it, you should be able to identify that you have a quadratic, okay? And that's a good thing because the only thing that we're missing is T. So this value in front of T squared is A. This value in front of T, including the minus sign, is B. And this value here that has nothing is C. Okay, so little refresher. Let's write the quadratic formula. And it has to be equal to 0. So the only way you can identify these three is if it's equal to 0. That's what the purpose of that was. So just a little review. We got T is equal to negative B plus or minus the square root of B squared minus 4AC over 2A. You need to memorize this just in case, okay? You can make an easy problem have a little bit of difficulty just by including a quadratic because people don't review that and that'll throw you off. The physics of it is relatively easy. This part right here is like killer for a lot of people. So memorize this and just be able to identify this situation. All right, so plugging things in. All right, let's plug things in. I'm gonna put T is equal to, okay, B here. I'm gonna put it, okay, let me just write it underneath it. 90 and sine of 23 is gonna be 35.2. Okay, so this number replaced all this in front of the T, and this is gonna be 4.9. Okay, so that's what I'm using for A. This is what I'm using for B. And C is 114. So we got T is equal to a negative number, so positive, which I did not need to write, but let's move on. Plus or minus the square root of B squared, so 35.2 squared, minus 4AC A is 4.9 and C is negative 114. Don't forget the negative sign in front of the number. That's very important, because now you can see that this negative and this negative cancel out underneath the root. If you have a negative under this root, you did something wrong, so check it. There should not be no imaginary numbers and stuff like that. Okay, and then underneath you got 2a, so 2, and then a is 4.9. Okay, so we plug that in to our calculator, which is the most annoying part, I feel, when taking exams, because this part is tricky. So I suggest you do it slowly and don't get the wrong answer just for calculator error, because I know I've made them and that's annoying. So we got time is equal to 9.6 seconds. So this package from up here landed a distance away from the dog in 9.6 seconds. Now let's take that info and find out what this distance is. What could we use to find that? Well, we used displacement in the y because we had a y value, and then we looked and we just so happened to have everything except for t. Fine, we found t. Now, what can we use for the x? Well, we can use the change in x, all right, the displacement in the x is equal to v initial cosine theta times time. Let's take a look. We got time, we got the angle already given to us, and we got velocity initial. Okay, so perfect. That's it. We got change in x is 90 times cosine of 23 times 9.6 seconds, and we're gonna get 795 meters, which is pretty far, but you know, the plane is going really fast and it's a pretty significant angle. So this number is big, but it makes sense. Okay, so this thing from here traveled 700, let's write it here. So this here is this value. So 795 meters is what the suitcase, little pink suitcase, traveled past the dog. That's very important. It's just this piece here. Okay, so pretty simple. This is a killer. So understand how to do this well, because to make an easy problem hard, all you got to do is throw in some algebra and students will mess up. So try to just get this down, and look how easy, you know, 1-2 step, and this would be 1-2 step if it wasn't for this craziness. All right, so hope it helped.